Introduction to C. History of C. The root of all modern languages is ALGOL, introduced in the early 1960s. ALGOL was the first computer language to use a block structure. Although it never became popular in USA, it was widely used in Europe. ALGOL gave the concept of structured programming to the computer science community. In 1967, Martin Richards developed a language called BCPL, that is, Basic Combined Programming Language, primarily for writing system software. In 1970, Ken Thompson created a language using many features of BCPL and called it simply B. B was used to create early versions of Unix operating system at Bell Laboratories. Both BCPL and B were typeless system programming languages. During 1970s, C had evolved into what is now known as traditional C. Considering the characteristics of C as why C has now become a widely used professional language. It has high-level constructs, it can handle low-level activities, it produces efficient programs, it can be compiled on a variety of computers. But its main drawback is that it has poor error detection, which can make it off-putting to the beginner. Importance of C. The increasing popularity of C is probably due to its many desirable qualities. It is a robust language whose rich set of built-in functions and operators can be used to write any complex program. The C compiler combines the capabilities of an assembly language with the features of a high-level language, and therefore it is well suited for writing both programs, system software, and business packages. In fact, many of the C compilers available in market are written in C. The programs written in C are many times faster than BASIC. There are only 32 keywords in ANSI C. C is highly portable. That means the C programs written for one computer can be run on another with little or no modification. Portability is important if we plan to use a new computer with a different operating system. Another important feature of C is its ability to extend itself. Basic structure of a C program. A C program basically has the following form. It includes the preprocessor commands followed by the type definitions, function prototypes, variables, and functions. A function is a subroutine that may include one or more statements designed to perform a specific task. The documentation section consists of a set of comment lines giving the name of the program, the author, and other details which the programmer would like to use later. The hash-define directive. A hash-define is a preprocessor compiler directive and not a statement. Therefore, hash-defined lines should not end with a semicolon. Symbolic constants are generally written in uppercase so that they are easily distinguished from lowercase variable names. Hash-defined instructions are usually placed at the beginning before the main function. Symbolic constants are not declared in declaration section. The main function. The main is a part of every C program. C permits different forms of main statement as stated here. The empty pair of parentheses indicates that the function has no arguments. This may be explicitly indicated by using the keyword void inside the parentheses. We may also specify the keyword int or void before the word main. The keyword void means that the function does not return any information to the operating system, and int means that the function returns an integer value to the operating system. When int is specified, the last statement in the program must be return 0. Executing the C program. Executing a program written in C involves a series of steps. They are creating the program, compiling the program, linking the program with functions that are needed from the C library, and executing the program. Although these steps remain the same irrespective of the operating system, system commands for implementing the steps and conventions for naming the files may differ from system to system. This slide has a sample program to illustrate the execution of the C programming and to illustrate how the output is obtained. This is a simple program to print a message. This slide illustrates the program to check whether the given number is odd or even. This is achieved by the condition of if and else statements. The syntax and semantics of if and else is dealt later. This is the output of the program to check whether a number is odd or even. Moving on to the next program to find the greatest of two numbers. Again, the concept of if-else statement is used here. This is the output of the program to find the greatest of two numbers. When two values are entered, the one the greater than the other is printed as the output.